but there are lots of questions to try. So just a recap of previous class before I move ahead. একটা জিনিস মনে রেখো, আচ্ছা, এই চ্যাপ্টারটা if you go to your textbook, it's I don't know, 6 pages or 5 pages, okay? A very brief topic. It's like a subtopic of a big topic, like further mechanics, like a small part. And you might feel like we've spent a month on this topic, right? Actually, a full month. So doesn't look like that from the things that we have in our textbook, or like, at least textbook. Why are we doing this? So that's the problem with this topic, that the fundamentals, the basics are quite straightforward. Okay, they're just 4 formulas. I keep bringing that box up wherever I go. There, right? That's it. I've derived them, I've told you what they mean, and that's the end of the chapter. Okay, but then using that idea, exam holo unseen paper, a question asche. And how would somebody just knowing those equations be able to solve this? That's just unrealistic. And they have been like this for the last, I don't know, since my time. Okay, so for almost 10-15 years they have been doing the same thing, right? A chapter logic খুব simple, questions গুলো একটু ঝামেলা করে দেয় এই জিনিসগুলো দিয়ে. That's why I'm trying to cover as many examples as possible, with a very important disclaimer. You might get something new in your exam, okay, that uses circular motion, definitely. Okay, and I'll actually appreciate if they give something new, so that next year our example at the very. But the point is, you have to be open-minded with this chapter, because I have seen students who go like, eta পড়া শেষ, question paper করতে যাব, and then they see like a random circular motion scenario, and then they start panicking, right? So you shouldn't be that. You should have to be open-minded that anything can show up. Okay, that being said, it can't go out of these 4 scenarios. Like, try to think of a circular motion with its forces changing and whatever. It will always boil down to these 4 scenarios where this is not possible at all, right? It is possible now. So at the end of the day, it's just these 3 out there. So 18 বাইরে কিন্তু হচ্ছে না. So you can like, come across almost any circular motion, and you'll find that it is based somehow loosely on these 3 that we have here. Okay, so yeah, that's the thing that I wanted to say. Question paper pulled out to push by what I'm trying to mean. So we did banking last class. What was banking? Banking is the idea that when you want to turn your vehicle, right, tilts, and plane especially, it tilts. Why does it tilt? So that it can create a component acting towards the center, and that component will allow you to generate centripetal force, right? Just like that. Now, it also happens with cars. It also happens with, I think I showed you the bobsleigh, the Olympic sport. So, a tiltingটা হচ্ছে ভালো, খারাপ না কিন্তু. So if you go on a road and you see roadটা tilt হয়ে যাচ্ছে এভাবে, most people will be worried যে গাড়ি পড়ে যাবে. না, actually গাড়িকে turn করতে help করতেছে. Okay, so it helps your car turn. Though there is a catch, which is if it goes very slowly, it's risky, because you need to have centripetal force to make you stick to the road, as they say. Okay, grip better hoy. So yeah, don't expect to be like this and stay still. Okay, that's the risky maneuver. Okay, anyways, so based on everything that I taught last class and the formulas of circular motion that we have, here is a question for you guys. A plane of mass 40,000 kilograms is turning at 60 meters per second. Planeটাকে turn করতে হচ্ছে at 60 meters per second. That plane has to maintain 60 meters per second while turning. Find the turn radius needed. So find for me, what radius does this turning of the plane, right? So the plane is turning here. What radius does it need to turn? If it's a 40,000 kilogram plane turning at 60 meters per second, okay? Find the radius needed. Now, it could be any answer, but it won't be any answer because I'm going to add a catch here. What's the catch? Catch হচ্ছে the plane is inclined at 30 degrees. So it's a passenger plane. You can't do acrobatics with it. So 30 degree বেশি tilt করতে পারবে না. So based on these information, can you tell me what radius the plane is going to take in order to turn, being 40,000 kilograms at 60 meters per second with 30 degree alignment or inclination? So try and tell me what the answers are. আমাদের এটা হয়ে গেলে we'll start momentum, which is the second part, further mechanics. What do you think is the answer? What's the turn radius? If you want, you can give me in meters, or you can give the answer in kilometers as well, if it's 3,000, 4,000, or correct value. All right, I have one answer, two, three answers. So one is 636. There is a 212, and there is 733. Okay, so 636, 212, 733. Any other answers? Six 636. Okay, so the common answer is 636, and there's a bit of 733 somewhere and 212. আচ্ছা, বাকিরা শেয়ার করতে থাকো. Let's see, তারপর আমি স্টার্ট করবো সলভ করতে. So হয়ে যাওয়ার কথা by now. If you want the formula or like the diagram is there. কি হবে, তাড়াতাড়ি করো. Right, 636 are the answer. Okay, so article answer, this a different answer. Maybe this could be the answer, but yeah, keep sharing your answers as I start solving this. So it says that the plane is of mass 40,000 and it's turning at 60 meter per second. Find the turn radius needed. So key করবো এই টাইপের question যখন দেয় আমাদেরকে, what do we do? So we obviously draw the plane and we draw its wings. Okay, simplified diagram. And then it says it's inclined at 30 degree, right? This is usually from the vertical, okay? Unless otherwise stated. Inclination is like that. So this is 0 and then there's an inclination, right? So if this was my initial vertical alignment, this is going to be the inclination, right? So this is my lift. And that is my 30 degrees. All right, আর কি কি জানি আমরা? আর আমরা জানি weight এক করে, so weight হচ্ছে নিচের দিকে এক করে হবে, so that is my weight. So there's weight acting downwards. All right, now we need to make this plane turn which way? This way, let's say, right? So the centripetal force is going to be this way. So centripetal force will dictate how much radius it's needed to turn, right? So how do we bring all of these things together? So first of all, দেখে এই derive করে কিছু করা যাবে না, আমরা যা আছে ওটা ইউজ করে করি, ওকে, বিকজ এক্সামে তোমাকে স্ক্র্যাচ থেকেই করতে হয়। সো ফার্স্টে what we do, we write down the weight. So weight is 40,000 into 9.81. Okay, and what else do we know? This is lift, so this is L sine theta, and this is L cos theta. Now my centripetal force Fc is equal to L sine 30. Simple, straightforward. Okay, centripetal force is L sine 30. কিন্তু প্রবলেমটা কোথায়? প্রবলেমটা হচ্ছে এই এই যে এই ভ্যালু যেটা এখানে হচ্ছে, we do not know. What do we don't know? We do not know the value of L, right? What is L? L টা তো জানি না আমরা। সো যেটা আমাদেরকে করতে হবে ফার্স্টে, we need to find L. সো এটা না লিখে ফার্স্ট what we do is resolving vertically. Okay, resolving vertically. So when resolving vertically, what is going to be the condition? Vertically মানে যে এভাবে, কিন্তু প্লেন তো পড়ে যাচ্ছে না, প্লেন তো উড়েও যাচ্ছে না, the same height টার্ন করতেছে। Generally ওইটাই কেস থাকে, sometimes they tell it, but most of the time it's assumed. So resolving vertically, L cos 30 is equal to mg, right? So I'll just keep it as mg right now. Upward force is equal to downward divided by cos 30. So that's the value of L that we have. Now what I do is I find it horizontally. So resolving, right? What do we have? Resolving horizontally. Fc, centripetal force, is equal to L sine 30. But I want the actual value, right? So what is that going to be? L is going to be mg divided by cos 30 times sine 30. Now I believe sometimes students কি করে, ওরা লিফট কে হচ্ছে ওয়েট এর সাথে ইকুয়াল করে ফেলে। Very good. I mean, that's actually true. But that's when the plane is flying horizontally. When the plane is tilted, the lift is not overcoming the weight. It's actually the component of lift that's overcoming the weight. So তার জন্য এখানে কিন্তু বসাতে পারবো না তোমরা, যেভাবে করছি এভাবে করে করতে হবে। So therefore centripetal force, right? So what's the formula for centripetal force? I want to find radius, right? So I'll use mv square by r. Why did I choose this equation and not m square r? Because we need the velocity, right? I asked you for the, sorry, we have the velocity. So I'll go for this. So m into 60 square is equal to m into 9.81 into tan 30, I believe, right? Tan 30. So from there, you see, as always, right, what happens is our mass gets canceled out. So mass cancels out, and we have an equation to find the radius. Make sure it's in degree mode, otherwise you'll make mistakes. So 60 square divided by 9.81 into tan 30. Tan 30 তে এই তোমাদের হচ্ছে ডিগ্রি মোডে নিতে হবে, নাহলে অ্যান্সার ঠিক আসবে না। ওকে, সো কি আসে এই ম্যাথটা করলে ওইটাই আমাদের অ্যান্সার। সো একটু কেউ শেয়ার করবা কি আসে অ্যান্সার, এই 60 স্কোয়ার ডিভাইডেড বাই অল দিস নাম্বারস। Is that the answer? So very good. Okay, if that's the correct answer, excellent, because a lot of some of you got it right very early on, so very good. So যে বুঝে গেল তো এরকমই কোয়েশ্চেন হবে। আচ্ছা, এটাই ধরো ডিফিকাল্টি 10 এর মধ্যে হচ্ছে লাইক আ 7, ওকে, অর এন 8। সো এটা পারলে আরো বাকিগুলো আশা করি ঝামেলা হবে না। Right, so there you have it. This plane needs to take almost half a kilometer radius to turn, because it's a fast moving plane at a small angle, okay? Acha, anyways, so এখন আমরা কি করব? So we'll start to solve several questions, okay? And through questions, I think we'll learn better, because you get a true view of what's expected, like exam কি আসতে পারে. So let's start solving these questions, okay, one by one. We will start with this one, and just a second. Right, so এটার answer কি? What's the answer to this? The diagram shows a coin on a horizontal surface which is rotating at a constant angular velocity omega. The arrow correctly shows the direction of the frictional force on the coin. Answer karo. I created a poll. Oi poll diye answer karo. Frictional force on the coin. This is also your attendance. So তোমরা যদি হচ্ছে answer নাও পারো, ভুল answer দাও একটা. At least I'll know you're in the class. What is the direction of the frictional force on the coin? এখনো অনেকে answer করো নাই। কি হবে answer? What is the direction of the frictional force on this coin? আচ্ছা, so কি বলছে এখানে? Let me end it. এখন কয়জন? 3, 4. Right. Okay, so let's stop. কি হবে এখানে answer? The diagram shows a coin on a horizontal surface rotating at a constant speed. So যে গোল হয়ে ঘুরতেছে এটা. And which arrow shows the frictional force on the coin? Now, this coin here is undergoing circular motion, obviously, right? This coin is undergoing circular motion. Which way does the coin need to experience a force in order to undergo circular motion? Towards the center, right? So this is the force that's needed to keep it towards the center. But they said the direction of the frictional force on the coin. Now, majority of you, right, unfortunately, you said that friction is in the direction of C. When will C be the friction? C friction হতো যদি আমি হচ্ছে কয়েনটাকে একটা টেবিলের উপরে এদিকে ধাক্কা দিয়ে নিয়ে যেতাম। মানে আমি কয়েনটার উপরে, let's say, press onto the coin, right, and I apply force and I move the coin like this. আমি কয়েনটাকে যদি হাত দিয়ে ভাবে সরাই ফেলতাম, এটা রোটেট করতেছে না, বাই দ্য ওয়ে, জাস্ট কয়েনটাকে যদি ধাক্কা দিয়ে নিয়ে যেতাম, ফ্রিকশন সি দিকে হইতো। বাট এই কয়েনটা কিন্তু মুভ করানো হচ্ছে না। It's a stationary coin on what? On a disc that's rotating. So যখন ডিস্কটা রোটেট করতে থাকি ভাবে, কয়েনটা কোন দিকে চলে যেতে যাচ্ছে? বাইরের দিকে। The coin is trying to move away from the center. It's trying to slip away from the center, right? So as the coin tries to slip away from the center, the coin applies, so just side view যদি দেখি আমরা, the coin applies a force on the surface here. Okay, এটা হচ্ছে side view, কয়েনটা বাইরের দিকে চলে যেতে যাচ্ছে, so the coin applies a force on the surface like that, and the surface applies a force back on the coin towards the center, and that is what force? Frictional force. ফ্রিকশন যে সবসময় মুভমেন্টের এগেইনস্টে হতে হবে এরকম কোনো জায়গায় লেখা নাই। ওকে, ফ্রিকশন ইজ অলওয়েজ গোইং টু বি এগেইনস্ট, মানে এগেইনস্ট দ্য মুভমেন্ট, মানে আই এম সেইং যে এদিকে মুভ করতেছে ওইদিকে তা না। ফ্রিকশন হচ্ছে ইজ দি ফোর্স এক্সার্টেড বাই সারফেস onto your object. And why would the surface apply a force onto your object? Because your object is trying to move. So to oppose it, friction is generated. So এখানে এ কেন হবে না? এ যদি ফোর্স হতো ফ্রিকশন, তা তো ইটস লাইক ইম্পসিবল। আই ডোন্ট নো হাউ সাম অফ ইউ স্টিল অ্যান্সার্ড এ। মানে ফ্রিকশন কেন সামনে হবে? ওকে, সো এ ইজ নট দি অ্যান্সার। আর যদি সামনে হইতো তার মানে অবজেক্টটা পিছিয়ে যাওয়ার চেষ্টা করতেছে, বাট সেটা না। এখানে তো বলছে দ্যাট শোজ ফ্রিকশনাল ফোর্স অন দ্য কয়েন। কয়েন অলরেডি সার্কেলে যাচ্ছে। অনেকে ভাবতে পারো কয়েন মেবি এভাবে চলে যাবে, না, ইটস ইন আ সার্কেল। ওকে, সো দ্য কয়েন ইজ ইন আ সার্কেল, right? Why would the force be that way or this way? So it has to be towards the center. So the correct answer is actually D. Okay, not C. C can both, I'm not really sure, but yeah, anyways, D is the correct answer. B cannot have, no, B would have been the right answer, but B is your the force that the coin applies on the floor. We are looking for the force that the floor applies on the coin, right? Is it the similar concept of a car moving in a roundabout? Yes, absolutely. Exactly the same thing. Okay. So for a coin moving in a circle and a car moving in a roundabout, the concepts are 100% same. Okay. গাড়িতে the tire applies the friction, the coin coiner surface applies the friction. Now এটা যদি polished একটা surface থাকতো, let's say we polish it. So it's a polished surface, right? In that case, Kyoto, if you try to spin it, the coin will fly right away. Why? It tries to go outwards, and because there's no friction, it does go outwards and fly off. Okay? আচ্ছা, এটা try করো. Second one. So, কি হবে answer? এটা একটা math, so একটু time লাগতে পারে, but try to finish it within a minute. A particle is moving in a circular path, complete 7.5 revolutions in 9 seconds. Its angular velocity in radian per second কত? What is the angular velocity in radians? তাড়াতাড়ি করো. Ideally, you shouldn't spend more than a couple of minutes on your MCQs. Acha. Okay, so let's discuss. Majority of you have given the answer as B. B is the majority answer. Okay, a couple of you gave A as the answer as well. Let's see what's going on. So let's discuss. Achha, so what does it say here? It says that a particle moving in a circular path completes 7.5 revolutions in 9 seconds. What's the velocity in radians per second, right? So omega is 2 pi by t. I just go using this formula. Okay, I mean 2 pi f by use for enough. So omega equals to 2 pi by t. So if 7.5 revolutions, right? 7.5 revolutions take how much? 9 seconds, right? 7.5 revolutions, 9 seconds. We need to find out what? We need to find out the time for one revolution. Why? Because time for one revolution represents time period, right? So if I find that, so that's x equals to 9 divided by 7.5. কত আসে? What's 9 divided by 7.5? 1.2. So 1.2 seconds is my time period. So therefore, omega is equal to 2 pi divided by 1.2. So that's the answer, okay? I'm guessing it's 5.2 ashe. So that's the answer. Mucho. 5.23. Okay, thank you. 5.23 seconds. Sorry, seconds. Radian per second. Is that okay? So just a unitary method to apply করো. I always recommend unitary method টা use করে করতে গেলে easier. I know maybe you might find যে না আমি mentally করতে পারি বা somehow করতে পারো frequency বের করে, whichever way works for you. But if it doesn't, then go for this, okay? এটা কি হবে? The angular speed of Earth about its axis. What is the angular speed of Earth around its axis? We did this before. Even if you can go back and look at the answer and tell me, তাও ভালো. At least that means you have it somewhere, right? So দেখো. The angular speed of Earth about its axis. What is it? Okay, so majority of you have answered. It was you who gave the D answer because সব হচ্ছে A and this is one person who gave D. Okay, anyways. কেমনে করবো এটা? So omega for Earth is 2 pi by T. 2 pi by T key time period for the Earth to go around in like a circle on its axis, on own axis, 24 hours. So 24 into 3600. Seconds convert করতে হবে. A is the answer. That's it, right? আর তো কিছু না. I think 7.27 বা কিছু একটা আসে because we do this math very frequently in our unit 5. All right, so আমরা হচ্ছে এটা করছিলাম, রাইট? আর আজকে এমসিকিউ গুলো করে একটা বড় কোয়েশ্চেন করার চেষ্টা করব। সো এটা করে নি, দিস ওয়ান বের করো। A racing car of mass 1200 kilogram travels at that speed around the bend of 50 meters. The force on the car necessary for this motion, মানে এই মোশনটাকে সাকসেসফুল করতে হলে how much force is necessary, কি হবে? So right away you can eliminate two answers. Okay, you know that it's not possible because of the direction, but rest তোমরা বলো কি হবে. So which one is the correct answer? তাড়াতাড়ি করো, what is the force necessary for this motion? মানে centripetal force-টা বের করো, তারপর হচ্ছে তোমার ডাইরেকশনের সাথে ম্যাচ করতে হবে কোন ডাইরেকশন হবে। All right, okay, so we are almost done. এখানে একটু দেখি। So the correct answer is based on what? It's based on F equals to M omega square r. So this is going to tell us what the value is, right? So mass koto, mass হচ্ছে 1200 into omega হচ্ছে 0.63 squared into 50, right? কি দেয় এটা? 2 point something something 10 to the power 4. This is centripetal force, right? This is the force needed to keep it in circle. Okay, so 2.38 into 10 to the power 4, right? 38 into 10 to the power 4 newtons. So I know that my answer is not C, right? C আর হতে পারবে না because 3.8, D হতে পারবে না 3.8. Now there are two options here, which is away from the center or towards the center of the circle. এটা তো ভুল হতেই পারে না, right? এখানে হচ্ছে away তো কোনোভাবে possible না, because centripetal force always acts towards the center of a circle. So the correct answer is going to be B. Okay, so B is the correct answer. Acha, so let's wrap up. Last একটা part, MCQ গুলোর মধ্যে. So this is a question. The photograph shows cars driving around a roundabout at a constant speed. So এই যে roundabout তে যাচ্ছে, right? The resultant force F on the car causes it to follow a circular path. Yes. Which of the following statements about F is incorrect? এই কোন স্টেটমেন্টটা wrong এখানে বলো? What statement is wrong in this scenario? What is which one is incorrect? Incorrect মানে কিন্তু which statement is not possible? Some of you have given the answer, the most obvious correct answer কে তোমরা হচ্ছে wrong বলতেছো. So incorrect হতে হবে কিন্তু which one is incorrect? All right, so answer হচ্ছে majority of you went for A. Okay, let's see what the answer is. Let me explain. So we have F equals to M omega square R. That's the formula, right? M omega square R, or we have mv square by R. So the question is, which is not true here, which is incorrect. So what is F? F is the resultant force, right? So by resultant force, what does it mean? It's the centripetal force. A resultant force when car is going in a circle is the centripetal force, the force acting towards the center, right? এখন a what are the points here? So there are two ways of answering this. One is the way of elimination, like we eliminate the right ones, and the other one is you directly figure out what's wrong. So let's eliminate the right ones first of all. Right ones one the statements that are right. So D দিয়ে start করি. F is perpendicular to the momentum of the car. Definitely, right? Why not? Because your car is traveling like this, right? So velocity এদিকে, momentum এদিকে, and the centripetal force always acts towards the center, perpendicular to your velocity. So yes, F is perpendicular to the momentum. Next বলছে F is in the same direction of the acceleration of the car. For some reason, I see that some of you went for this, but এটা তো the most obvious answer হওয়ার কথা ছিল. Your centripetal force is in the direction of the acceleration, right? So acceleration দিকে ওইদিকে তো force হয়. Anyways, কোনো কারণে maybe confused হয়ে গেছে. This is also correct, by the way. So these are correct statements. Nothing wrong about that. Now comes this. F is equal to the product of mass and angular velocity of the car. So they're saying that F is equal to M omega. We never seen a formula like that. So maybe this is not true. Our particle F is equal to the product of momentum and angular velocity of the car. So F is equal to momentum times angular velocity. আচ্ছা এটা আমি দেখি নাই, দেখি এটা কাজ করে নাকি। So momentum কি mass into velocity and angular velocity হচ্ছে omega. Then M V equals to omega R. So omega R times omega. So M omega square R. Okay, so that's actually a formula. And if you remember, আমি তোমাদেরকে প্রথমে দিকে বলছিলাম এরকম একটা ফর্মুলা এক্সিস্ট করে, বাট আমাদের হচ্ছে দরকার নাই বিকজ এটা ওরকম কাজে কোনো সময় দেয় না। ওকে, সো আমি কোথায় ফর্মুলাটা ছিল একটু দেখাই তোমাদেরকে। There was a place was it batch নাকি Cambridge? Just give me a second. I remember seeing it somewhere. V omega equals to V omega. আচ্ছা এটাই ছিল। So you can use this to get that. মানে V omega and mv যদি আমি বুঝাইনি জিনিসটা। This is A equals to V omega, right? So if I multiply mass on both sides, so your mass gives you F and V into mass gives you momentum. So a derivation. Okay, it's more popular in Cambridge or used at least. তোমাদের দরকার নেই, বাট ইয়া এই টাইপের এমসিকিউতে মেবি একটু হেল্প হইতো, বাট এগুলোর জন্য আলাদা করে একটা ফর্মুলা মনে রাখা আমার মনে হয় না দরকার। ওকে, সো তোমরা ডিরাইভ করে বের করতে পারতে, যেটা আমি করলাম। আমি কি করছি, ওরা বলছে মোমেন্টাম আর অ্যাঙ্গুলার স্পিড হচ্ছে ফোর্স দেয়, সো আমি ব্রেকডাউন করে দেখলাম অ্যাকচুয়ালি ট্রু নাকি, এন্ড ইট ইজ ট্রু, এম ওমেগা স্কোয়ার আসে। সো ইউ ক্যান প্রবাবলি ফিগার আউট নাও দ্যাট is the incorrect statement. Okay, আচ্ছা, সো এখানে কিছু কোয়েশ্চেন আছে ইন্টারেস্টিং, আমরা একটা ট্রাই করি। এই যে এটা, সো I'll upload these things. I think I might have already done, but তার আগে এটা দেখো। সো ফার্স্ট অফ অল হচ্ছে ডিফাইন রেডিয়ান। এই ডিফাইন রেডিয়ানটা দরকার নেই আমাদের, এটা হচ্ছে কেমব্রিজে আসে, সো এটা আমরা করবো না, আমরা এই ম্যাথটা করতে চাই। সো প্র্যাকটিসের জন্য I'm not going to waste Excel questions. Okay, so I have given some Cambridge questions here. Excel question হচ্ছে যে এইটা আর এইটা, এটা আমরা পরে করব, these. Okay, so Right. So a question do this. এটা আজকের ক্লাস এটাই শেষ। মেবি হচ্ছে একটা দুটো কোয়েশ্চেন করবো or we'll start or we'll do both. So এই যে answer weight 3 Newton is fixed of a rigid rod CP as shown. The rod is rotated about C so that stone moves in a vertical circle of radius 85 centimeters. The angular speed omega of the rod and the stone gradually increase from 0 until the glue snaps. So এটাকে spin করা হচ্ছে. So they're basically spinning this, right? So like that. And as they keep spinning this at high speeds, right, at a point here, the rope tears. Okay, the rope or this glue comes off. So কি বলছে, the glue snaps. The glue fixing the stone snaps when the tension is 80 Newton. So the glue actually has a maximum force after which it snaps, right? For the position of the stone at which the glue snaps, right? On the dotted circle, mark the letter S. So can you tell me where in this circle is it most likely that the stone will snap? মানে স্টোনটা ছুটে যাবে কোন পয়েন্টে, টপ, বটম, লেফট, রাইট, কোথায়? Where do you think the stone is most likely to snap? Right, so Anjuba, you are correct. Right, Nafis, you are correct as well. Bakira, where do you think it's going to snap? Right, exactly. The correct answer is going to be নিচের দিকে. It's going to be S here, AJ, bottom. Okay, so it's going to be at that point. So you have to mark that S. So the niche dige hobe, bottom of the correct answer is bottom. If you want to mark, it's going to be at the base. The next question is calculate the angular speed of the stone. So can you find for me the angular speed? মানে যেই স্পিডে তোমার হচ্ছে the stone snaps. What's the omega at which the stone snaps? It is. It snaps here, right? Bottom. One of you said at the edge. Edge, একটা circle to কোনো edge নাই, right? So how do you explain an edge of a circle? So bottom of the answer, এটা. Acha, calculate the angular speed of the stone. Find that for me. That's important. That's 4 marks. Yeah, that's 4 marks. At what speed does it snap? So এটা গোল করে ঘোরানো হচ্ছে, স্পিড বাড়াচ্ছ ওমেগা, কোন ওমেগাতে এটা ছিঁড়ে যাবে, মানে তোমার হচ্ছে কোনটা এটা, the glue will snap. So we have an answer here. This is 50. Right, I think that's the answer. Nafis, your one is correct. Same with Bushra and Tanim. Very good. Bakira Tricro, it's an easy question and it's a good question as a benchmark. যেটা যদি পারো তাহলে I think you're okay with circular motion. So যারা answer করতে পারছো so far, you should do fine. Right, so another correct answer. This is from Priyanti. Yes, that's the correct answer. বাকিদের answer গুলো একটু problem আছে, so একটু check করে দেখো. I'll give a couple of minutes more, so keep sharing your answers. Okay, so the majority of the answers 7.6 আসছে, but our 8.32 অনেকের আসছে, so I think it was 7.6. করে দেখতে হবে. 7.6 seems the correct answer. But anyways, a lot of you gave 7.6 now, so let me solve and show you the correct answer. Okay, so we need to find the omega. We need to find the omega when it snaps. How do we do that? So what we do is we look for what are the equations that control this point. So the centripetal force here is going to be the tension plus weight. Now this you have to figure out. Not like you have to figure out, but examine, at least you have to recall, because I already showed this thing multiple times already. Okay, so you have to know this equation. Can it equal? Okay, so you can go back and see vertical circular bottom FC equals to T plus mg. So that means FC is equal to T plus mg. So I need to find out when the T is 18, right? So how do I do that? So m omega square r is equal to 18 plus m into 9.81. Do we know m? Oh, we do know. Acha, we can find m. So mg, so 3 equals to 9.81 times m. So the mass is 3 divided by 9.81. So if I place my value here, I get 3 divided by 9.81 times omega square times radius is 85. So 85 divided by 100 is equal to 18 plus 3 divided by 9.81 once again into necessary children, sorry. But yeah, anyways, এটা করে তোমরা যেটা আসবে, so I'm guessing omega আসে হচ্ছে 7.6, right? If we do that, so 7.6 is the correct answer. 7.6. So there you go. Was that difficult? I don't think so. I mean, just a formula take your recall kora and then just placing the values in the equation. That was it, right? So yeah, this is a good test. That do you know how to apply the equations and whatnot? They ask you to derive this, they won't, because they feel that the student should be able to look at the setup and figure that out. So it is কোনো extra derive করতে বলেন না. Of course, there's a mark to write this down later on. আচ্ছা, আর s টাও সেই জায়গায় হবে. Anyways, I will upload these questions if I haven't already. I want you guys to try this question. Okay, this is very interesting. A part. Okay, at least this part. This is very interesting. Like the question. Okay, 8.99 kg answer. Did you try this question? Like answer 8.9 Wait, this one is 8.99. Let me check. Doesn't seem so, but I'll check. Let me see. Where's my calculator? 8.99. 3 divided by 9.81. Maybe I made a mistake somewhere. Into 85 divided by 100. Oh, acha. Right. Sorry, I made a mistake somewhere. It is T equation. Thank you. T is equal to, or Fc equals to T minus mg. I made a mistake with tension. So this Fc plus mg. My bad. Okay. So এটা যদি apply করি এখানে কিছু না, just এদিক ওদিক করতে হবে, plus minus, that's it. So this is going to be T equals to Fc minus plus mg. আচ্ছা, so T এদিকে and this and that. So what's the difference here? This is just going to become minus. Okay. এটা করলে কি আসে দাও দেখে নেই। So divide by 100 and 15. So 15 root answer. Yeah, আসে তো। Okay, so yeah, this is going to be the answer. Okay, so one of you has a question, which is why is it going to be at the bottom? Why does it snap at the bottom? So if you look at the equations of tension, right? Tension and value gulo kothay ki hoy? Vertical circular motion. The top formula for tension is T equals to, or at least এভাবে যদি করি, Fc equals to T plus mg, because both of them are acting downwards. So therefore T equals to Fc minus mg. And ekhane T equals to Fc. So is it on this side as well, where it is T equals to Fc? So if you look at the equations for tension, this is tension is equal to centripetal force minus weight. This is tension equals to centripetal force. This is tension equal to centripetal force. And this one is tension equals to centripetal force plus weight. So where do you think it's going to snap easily, where the force of tension is the greatest? Where is the force of tension the greatest? See, এখানে Fc, 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 সব জায়গায় Fc। একটা Fc থেকে মাইনাস হচ্ছে mg, এখানে কিছু হচ্ছে না, এখানে কিছু হচ্ছে না, এখানে Fc এর সাথে weight add হচ্ছে। So where in this circular motion is the tension the greatest? At the bottom, right? Mathematically speaking. So that's why at the bottom it's most likely to snap. Right, so যে বাকি কোয়েশ্চেন্স গুলো আপলোড করে দিব, তোমরা ট্রাই করে নিও। নেক্সট ক্লাসে আমরা এগুলো করবো। এগুলো যদি নেক্সট ক্লাসের মধ্যে করে ফেলতে পারি, you might have a test, or we might start test মানে few MCQ questions, or we might start momentum. Okay, so yeah, I'll see you guys next class.